All right. Good afternoon. Can you hear me okay? Welcome. So it's my pleasure to welcome everyone to the Rosenstiel School for our Climate Café series. We're pleased you've joined us, and thank you for coming to listen all about heat. My name is Deanna Udell. I have the honor and the pleasure of being the Director of Communications and Public Relations here at the Rosenstiel School. And the Climate Café series, we launched it virtually back in 2020 in response to the pandemic. And it was a way for us to design a series that would keep our scientists and students in a way to stay connected with our donors and alumni, collaborators, supporters, and to highlight, most importantly, the climate research happening here at the Rosenstiel School. As you know, these types of events don't happen without the support of dedicated donors, and we'd like to take just a moment to thank our Climate Café sponsors. Our presenting sponsor, many of you may know, is William J. Galway III. Bill has been a friend and supporter. Yep. Bill has been a friend and supporter of our school for the past 8 years. He also supports and continues to support the Sea Secrets Lecture Series, which will kick off again in January of 2024. Bill was a major sponsor of our 2020 Miami Climate Symposium, and we're very grateful for his ongoing support. Bill, please stand up. Thank you. So you may have seen the beautiful electric vehicle that's parked in our courtyard as you arrived and to our campus. It's quite a beauty. If you haven't checked it out, do so before you leave. There's a QR code on it, and also you can go online and check out the vehicles. We're very pleased to welcome Polestar as our corporate sponsor for the Climate Café. Here's a short video just to familiarize you with who they are. Yeah, silence your phones. That would be great.
Polestar started with a vision. The vision of a new electric car company dedicated to design and sustainability. A brand that brings passion and joy to driving an EV. Today, we have over 2,200 employees across the globe realizing that vision, pushing to improve the society we live in by accelerating the shift towards sustainable mobility. Our brand combines Scandinavian high-tech minimalism with avant-garde design and tech innovation. We are a credible and trusted car company. We're not looking for investment to build a business. We're looking to accelerate our growth. We have 55,000 cars on the road today, vehicles that have captured imaginations and been recognized with over 100 awards around the globe. We are up and running in 25 markets, with over 100 retail locations and 800 service points. We plan to continue this rapid expansion to be present in 30 markets, with an even bigger retail and service footprint by the end of 2023. We are expanding our product range with 3 new electric models, including 2 SUVs, joining our portfolio by 2024. The first of those new models, the Polestar 3 electric performance SUV, will set a new standard in this high-margin premium segment. This is the SUV for the electric age. We want to build electric vehicles that push the boundaries of sustainability, design, and technology, all with our performance DNA at the core. This includes our industry-leading ambition to produce a truly climate-neutral car by 2030. Our cars are on roads, not on PowerPoint slides. Our revenues are real, not a financial forecast. And our next vehicles are being designed and engineered. They are well advanced in their development. Our products address the fastest growing and highest margin vehicle segments across the globe. The end of emissions is coming. Polestar is what comes next.
I'd like to introduce you to Nabil Dean. He is the Regional Operations Manager for Southern U.S. at Polestar. If you want to buy a car, talk to this man. He's right here. Nabil, stand up and say hello, and thank you for your partnership on this. We really appreciate it. So without further delay, because we have a lot to cover, let's get the conversation going. We'll have an opportunity for questions at the end. Our moderator tonight is none other than one of South Florida's finest environmental reporters, WLRN's Jenny Staletovich. Thank you, WLRN, for your friendship and also your partnership. Jenny's been a journalist working in Florida for over 30 years. She's reported on some of the region's major environment stories, including the 2018 devastating red tide and blue-green algae blooms, impacts from climate change in the Everglades restoration. She's also written about disappearing rare forests, invasive pythons, diseased coral, and a host of other critical issues around the state. Jenny's won several state and national awards, including a Scripps Howard National Journalism Award for Distinguished Service for the First Amendment, the Green Eye Shades, Sunshine State Awards, and most recently a National Edward R. Murrow Award for her extensive coverage on the python. Jenny, come on up. Got you a little table here. All right. Jenny's first chair. Next, please welcome our scientists. Ben Kirtman, come on up. Ben is the William R. Middleton III Endowed Chair of Earth Sciences with an expertise in atmospheric sciences and director of our NOAA Cooperative Institute for Marine and Atmospheric Studies, also known as CMAS. Dr. Kirtman's research aims to understand and quantify the limits of climate predictability from days to decades. Amy Clement, come on up. Amy is a professor of atmospheric sciences. Dr. Clement studies the causes of climate change on all time scales from glacial period to future climate change. We also have Lynée Turek Hankins. Lynée is a doctoral student studying how infrastructure and policy can promote resilience and equity under a changing climate. Michael Studivan. Michael is an assistant scientist at CMAS. His research involves the use of advanced molecular techniques to better understand coral physiology and adaptation, as well as genetic connectivity of coral ecosystems in marginal environments. And last but not least, Dr. Andrew Baker, professor of marine biology and ecology. Dr. Baker's research focuses on coral reefs and climate change and the development and testing of methods to increase coral reef resilience. We also want to invite up Jane Gilbert, recognize Jane Gilbert, who is our Chief Heat Officer for Miami-Dade County, and our stakeholder. Come on up. And I want to introduce you to Morgan Elmer, who will switch out with Andrew Baker when Andrew's done talking. Morgan is the Natural Resources Chief from Biscayne National Park and also a major stakeholder. So, Jenny, take it away.
Okay, so we have a full stage and a lot to talk about. So we're going to start with Ben Kirtman, who is, I hope, going to explain to us what conditions were happening that set up this summer. We know we had record heat on land and sea. What happened?
Great question. This is a really cool picture. If you're a scientist, this is a really cool picture. If you're a human living on Earth, this is a scary picture. What you can see is this is the annual cycle of temperatures around the globe, and you can see there's just the steady progression of the colors, the warming that happens, and then all of a sudden you get to 2023, and that's that black curve at the top, and you can just see that my good friend and colleague Brian McNulty called this bonkers. It really is bonkers. The warming we're seeing this year is unprecedented. And we don't really know why. There's lots of potential culprits. Certainly climate change is a big one. There's less pollution, allowing the Earth to absorb more sunlight, which tends to warm up the Earth. That's probably a contributor. El Nino, the ongoing El Nino, is also very likely a contributor. But even the sum of those three won't fully explain what's going on. So this is going to be an area of research for many weeks, months, and years to really understand why the climate system ratcheted up in terms of its warmth over such a short period of time.
And can you explain or talk a little bit about how that heat on land and in the air heated up the ocean? When we talked before, you had said this ocean heat wave was just unprecedented.
Locally, it was just crazy. When you think about, all around Peninsula Florida, the temperatures were very, very close to dangerous, where it was dangerous to go in the water. It was just astronomical. Again, we can predict these heat waves to some degree, but this particular heat wave that we saw, or that surrounded Peninsula Florida on both sides, was absolutely unprecedented, and we don't really know why. What happened?
Is it a factor of currents and the
The currents are definitely part of it. There's arguments that we may see a slowing down of the whole current system that brings warm water up to towards the poles. That could be part of it. Again, less pollution. But the waters were so incredibly warm that all of our usual explanations are not a complete story of what's going on there. So there is really a lot of work that needs to be done to understand, but it's not normal. My instincts tell me that this isn't a paradigm shift, a new world that we've all gone to, but we do see climate change. When you look at past records, there are ratcheting up of the signal, and this could be part of that ratcheting up of the climate change signal that we're seeing. We'll know eventually.
And we had talked about this before, and you explained that when things ratchet up, they don't really ratchet back down.
They don't
That's
ratchet back down.
Worrisome thing.
That's right. That's right. So we don't, I wish I could get up here and say, oh yeah, I know exactly why that happened. It's this, but we just don't know.
And just one last thing, in the last United Nations IPC report, they warned of an increase in frequency of these ocean heat waves.
Yes.
And is that just a factor of the warming planet, or is the warming planet doing something to the oceans? And I'm sorry, this is like a super broad question. So.
I think it's, the oceans are absorbing so much more heat. And so, the fact that the oceans are absorbing so much more heat, the CO2 content in the oceans is so much higher. All of these things are contributing to an increased frequency of heat waves. And so you can see this on this picture. This is the temperatures for September 2023. In most of these places that are really red, those are record temperatures forever in the modern instrument since the 1850s. So most of those places that are really red there, they're setting records that are unprecedented in the entire modern instrument record that we've ever seen. So it's happening everywhere. The climate system is warming up like mad. And in fact, one of the interesting things, a little gossipy thing about this picture, it's produced by a group that originally believed that guys like me and Amy that produced these climate maps, we were doing it wrong. That we didn't know how to estimate what temperatures were. This group, this Berkeley group, now is a firm believer in climate change. They've reproduced the results that we've produced, and so these guys are converts to this question of if the climate system is warming. So this is a really interesting group that's producing some of these maps. So that warming is bonkers.
And you can see the land masses are
right.
A lot red.
And if you go to the next one, the next one is just over North America, and this is now in terms of extremes, right? And so you, oh no, this is the whole globe. So you can see this is where everything. Sorry, I forgot. This is where everything warmed up. How did it rank over this 1850 to the present? And you can see all of those places that were orangey and red are now records. Really, really quite remarkable. Over land and ocean, not just land, not just ocean.
Wow.
And you can see the southeast, the U.S. Really got hammered this year. July and June and August and September, really, really bad. Over here, it's more, here in Florida, it's a little bit more complicated. We were suffering because it was so warm, but the moisture also had been a big part of it. And I think that's because the ocean around us was so warm that allows a lot more evaporation, so there's a lot more humidity in the air. So the humidity effect is also really important for us in our comfort levels.
And I looked at the El Nino forecast for the year, and I think there's an 80% chance that it'll last through next spring. So is that foreshadow another hot summer next year?
I think so. It's certainly not going to transition to a La Nina before then, before next summer. So I think we're going to see persistent warm temperatures through much of the southeast U.S.
Okay. And so Amy, you took a look at this heat locally and what was happening. Can you talk a little bit about the study that you did?
Yeah, so we'll transition from that global map to a very, very hyper-local map, or some data that we have. So this is a picture, just to provide a little bit of a historical context. We've heard about the record year this summer. I think there were something like 50 advisory days where the heat index, which is a measure of how hot it feels, not how high the temperature is, but how hot it feels, because it combines, as Ben mentioned, humidity. 50 days in excess of what the National Weather Service considers dangerous for here in Florida, in South Florida. And so if we look back in time, not only was, this gives a little bit of context of how unprecedented those numbers are for this year, but that's not really the point I want to make. And I'll lead you to that, my next point in a moment. What I want to say is historically, Miami has not experienced extreme levels of heat that trigger advisory thresholds. So if you can't really see the details, I know this projector is a little dim, but if you look at the black bars on the bottom, those are historically the triggers of heat advisory thresholds from the National Weather Service. And what you basically see is you can't see them. And so from that perspective, it sort of seemed like, well, heat has never been like a dangerous problem. And Jane Gilbert's here. We have partnered, Jane has really pushed for changing that threshold. That's a whole other story, which I'm not going to get into right now. I want to keep things simple.
But I think you should mention that the advisories did change based on you guys lobbying the National Weather Service to lower the threshold.
Right,
to
so
reflect the danger.
The threshold has traditionally been 108, which is those black bars, and this year they did lower it to 105 based on advocacy by Jane and researchers, including myself and Lynée. So it was a big effort, and ironically, it was the year that we probably would have gotten past these 108-degree thresholds anyway. But what I want to transition to is to say that those levels of, that's, thinking about how heat comes in waves and goes away. But here in Florida, that's not how it is. And I think this year is an even more glaring issue, which is that, or a glaring illustration of that, which is that we had an entire summer where there was no respite from heat. And that is according to these National Weather Service monitoring stations. But what we did in addition to that is to say, well, how representative of the whole entire county is the airport? And what we did was we worked, if you can advance one, click.
And just so people understand, like when you hear a temperature from the National Weather Service, it's based on where their official monitor is. And for us in Miami, it's at the airport. Fort Lauderdale has one at their airport. So it's not like an average of many different gauges all over the place to give us a better sense. So, sorry.
It's so nice to have a professional science communicator here to help translate.
I stopped you and I'm like, wait, do I know that?
An award-winning one, no less. Right, okay, so what we tried to do was get a better picture of what was going on out in the community, where people were living, in parks, at bus stops. And this is a picture of a couple of our students placing these little low-cost sensors underneath a tree in a park, and the sensors would sit out there for 3 months, and we'd pull them in and look and analyze the data. And when we did that, and we corrected for what was actually happening out in the community, this same picture now converts to, go ahead, this picture. Oh, wow. So this shows you that out in our community, there are dangerous levels of heat nearly a third of the year, and dangerous by the old threshold, which was 108 degrees of heat index, nearly a third of the year. And I think anybody in this room that was in South Florida this summer experienced that physically as well. And so what we have been trying to do, in addition to documenting what heat is like for people living in the community, is also arguing for a different approach to heat management, where heat doesn't come in waves, and when they go away, you get respite from it. But how does a community adapt to a place where we may have 50, 60, 70 consecutive days of extremely dangerous heat? How do we do that? And we're trying to tee up the research to do that. And I'm just going to plug Lynée because she has the answers, but I'll stop there.
Okay, because yes, Lynée is you actually went and knocked on doors and went into people's houses, so I wanted to ask you about that, what you found, and if you have recommendations.
Yeah, absolutely. So what they're talking about is a study that I had the pleasure of working on with several other people at the University of Miami and Catalyst Miami as well, who was our nonprofit partner. And what we ended up doing was we heard from multiple community members in multiple settings that heat was a significant problem for them at home. And the challenge for us as scientists is so much of our data that is available for us is not in people's homes, right? We're talking about the airport. Maybe we're talking about out in the neighborhoods using satellite data, but we're not actually capturing what's inside, what people are dealing with when they go home after a long day of work. And this was the concern that they had. And so what we ended up doing was we created this study with Catalyst in which we recruited 57 households. And these were households that said, I am having issues with heat at home. And we didn't say, what temperature are you at? We let them kind of define what was too much for them. And what was really interesting about that project was the span of people who said they were having problems. I think we tend to think about low-income homes, people maybe who are in extreme poverty, but we actually had a lot of middle-income homes. And I think one of the things that was really shocking as well that I had not anticipated when you're sitting in somebody's home, you're at their dinner table, they're giving you a cafecito, you're having this really intense conversation with them about this thing that they're struggling with at home, and there's a lot of shame wrapped up in it. And so what we hear when we go to county meetings is people saying, hey, heat's not a problem. We all have air conditioning. It's fine. I go from my air-conditioned house to my air-conditioned car to my air-conditioned job. But that's not really what's happening for a lot of people, and they feel embarrassed about speaking up about it. And so it was honestly such a privilege to be able to be hosted in people's homes, to be talking about heat. And I think the thing that's really kind of worrying for me is we did that study last year in 2022, and we had many households that were hotter inside than they were outside. That means the house, the structure, was retaining significant heat, and that they were significantly exposed inside. And so if that was last year, I can't even imagine what it would have looked like if we did this same project this year.
And then we'll talk to Jane, because a lot of the information you got, Jane is then turning into using it to make recommendations to the county. So we're going to pivot to coral now, from land to sea. And Michael, if you could talk a little bit about this sort of, again, I hate to keep using the word unprecedented, but this bleaching event this summer that we heard so much about, because it was just worse than anything I've seen before.
Sure. Well, so I think a lot of us in the research community knew that something was coming. That we knew that this was likely going to be a coral bleaching year, where we have sustained high temperatures that lead to a breakdown of the very delicate symbiosis that corals have with their resident algae, which causes them to expel that algae, and it's slowly starving to death. So we sort of knew that it was coming, but what really surprised everybody in the research community is how early it came. Almost a month earlier, we were seeing temperatures towards that we would see in previous years in the end of the summer. We were seeing it in the middle of the summer. And so nobody was ready for it. And coral started bleaching quite rapidly all throughout the Florida's coral reef. In the entire Florida Keys into South Florida here. Now some of the northern regions were a bit spared because they typically get a nice cool upwelling during the summer around that same time, but it really hit hard, especially in this area.
And can you put in context a little bit, I should have asked you, first of all, to kind of give us a status report of our reefs, because we hear so much about them and how much they're struggling the last few years, since 2014 when it first first appeared. Stony coral disease hit those boulder corals really hard. So you're struggling with stony coral disease, and then boom, here comes this bleaching event that I believe, correct me if I'm wrong, it was the staghorn and the elk, those upper coral bleached first. Is that right? And then the boulder coral?
Everything has bleached.
Everything, okay.
For the most part, at least.
But so what was the reef like before the bleaching? And then now, as you said, you've had bleaching on average 90% from the Keys on up.
Sure. Well, I'm a relative newcomer to the field, so I don't have that frame of reference for what reefs in the Florida Keys looked like in the 70s, where we had these very dense thickets of staghorn and elkhorn corals. All that I remember is what looks like almost like a parking lot with a couple corals here and there. And so what I thought is that corals were looking decently well. I mean, like you mentioned, we've been responding to a disease outbreak for going on 9 years now, and so we've lost millions of corals throughout Florida. But going into this summer, things were quieting down a little bit. Disease was ebbing a little bit because it's just been here for so long. And then now, everything is affected. You go to certain sites and every single coral was bleached in July. We had soft corals, what we can see waving in this video here, they just completely melt. They just kind of fall apart. And it's just utter death and destruction everywhere you go. And
because we have, I would like to include me, but not me, but so much work has been done on restoration. I mean, it felt like a lot in response to stony coral, but just overall conditions and staghorn nurseries, outplantings and stuff. What happened to those, though? I mean, I feel like that was another moment where we were like, wow, we were really hoping to make progress in restoring the reef, and then here comes this bleaching event.
Coral restoration has really ramped up in the last several decades, and we've had the largest number of restoration efforts ever. And some of the biggest restoration projects are here in Florida. One of which is called Mission Iconic Reefs. It's meant to restore 7 iconic sites in the Florida Keys. And there were reports that every single outplant at some of their sites died as a result of the bleaching event. And that is the biggest restoration effort that we've ever taken. To see it just completely wiped off the map is terrifying. We've also been trying to increase our restoration efforts with other species beyond those fast-growing branching species. So those massive species that grow really slowly, but tend to form these large structures that form critical habitat. And those are affected as well. And so if there's a glimmer of hope here, it's that this bleaching event mobilized researchers and restoration practitioners and aquarium hobbyists to get out there as quickly as possible and to try and rescue as many corals as possible. And it was amazing. I mean, email chains that were 200 emails deep of people saying, I know of this site that has these corals. Can someone take them? Or someone saying, I have these extra tanks. We have corals inside our research tanks right now that are holding restoration corals that were rescued from the field. And we're still waiting to put them back. It's still quite warm, and we're just waiting for temperatures to come back down to actually put them back out on the reef.
Well, and I know we're still sort of in the midst of it, as you mentioned, but are there lessons learned, like going forward? It's sometimes a crisis can teach us things. We talked about scaling up some of the restoration efforts. Can you talk a little bit about that?
Absolutely. It's all a matter of scale at this point. What Jenny and I were discussing earlier is that as a society, we have industrialized agriculture. We can grow crops, we can raise livestock at enormous scales, and yet we have not done that yet with coral husbandry. So if we can create infrastructure to grow literally millions of corals, then we stand a fighting chance of being able to make a big dent in our declining reef populations until we get climate or carbon emissions under control. So I think a really important thing right now is to just invest heavily in infrastructure and personnel to be able to grow corals on land, because we can't trust the ocean anymore, because every couple of years it's one more thing.
Thank you. And I think actually this would be a good pivot to you, Andrew, to talk about the resilient coral. Like there is, growing coral is great, but we also, as long as the planet is warming, we need to think about the kind of coral that we're putting back out there to give them a fighting chance.
Yes, thanks, Jenny. Let's see. So Mike just talked about the severity of the coral bleaching that we saw in the Florida Keys. And I think earlier on, Ben had shown some graphs that is kind of similar to the one I'm going to point you to here. What this shows is coral biologists like to measure how much thermal stress is accumulated on a coral by looking at how warm the temperatures were and for how long. And they produce these measures of this accumulated thermal stress that you can kind of see in the image back here. And what Mike mentioned earlier on, this is 2023, and you can see that the kinds of bleaching that we normally get kind of normally accumulate here at low levels in September, August to September and extending into October. This accumulated thermal stress began literally on the 1st of July, and it's been with us ever since. The amount of thermal stress is accumulated to 2, 3, or even 4 times more than any previous event we've seen. And although the temperature stress is coming down, you can see that black line starting to come down as we move into October, the total load of thermal stress on these reefs has really broken the camel's back in many cases. However, there is some small amount of good news scattered amongst all of the bad headlines, which is that there is a gradient in response among corals. Some corals bleach more than others. Many corals, especially the elkhorn and staghorn corals, the corals that have been iconic to a lot of Florida's shallow reefs and have been the subject for a lot of restoration efforts, many of those have bleached and died already. But there are plenty of other species that are not doing quite as badly. And in fact, there's a gradient from inshore to offshore, with inshore corals generally receiving a lot more heat stress and suffering really badly, and the offshore corals doing somewhat better. There's a gradient from shallow to deep, which also kind of matches that inshore to offshore gradient. But the one I want to point out here is actually this gradient from south to north. So if you move from Key West all the way up through the Keys and up into Miami, there's a distinct gradient in coral response. And this plot that you see here is from the northern tip of Key Largo, a place called Carey's Fort, where the bleaching is really bad. You saw some video footage right now of areas fairly close to that, with the elkhorn corals really bleached and in some cases already dead. But as you move further north from Key Largo and up into Biscayne Bay and eventually up into Miami-Dade and right here off Key Biscayne, the bleaching gets progressively less. And in fact, in the middle of Biscayne National Park, just 10, 15 miles south of here, the bleaching is much more patchy. There are still some corals doing really badly, but there are corals that are also surviving rather well. And when you get up to Miami-Dade, in fact, right here off of Key Biscayne, we see sort of paling of corals, not much bleaching, a little bit of patchy bleaching, but no mortality. And the reason I wanted to mention that is that the reefs here off of Miami have still seen almost as much thermal stress as the reefs further south. You can see that black line here, again, showing just how unusual it was. It's not quite as bad, but it's still well off the charts of anything reefs anywhere in Florida have experienced. And yet these corals in Miami-Dade are doing rather well. So here's some photos, by the way, of the reefs off of Miami. You can see that there are some bleached staghorn corals in the lower right. You can see some patchy bleaching in some massives. But you can see also that corals are also doing relatively well. So there's definitely opportunity to use, Jenny asked about is there any opportunities from this? And there are opportunities to study why some corals do better than others. And it kind of ties to the fact that, we're just beginning to appreciate not only are coral reefs, warehouses of biodiversity, that are, the rainforests of the ocean, home to millions of often undescribed species, but they're also increasingly valued for their coastal protection benefits. We are actually here in Southeast Florida, almost the epicenter in the world for the amount of flood protection benefits that corals provide us with in the event of even just a 10-year storm. Coral reefs in Southeast Florida, mainly in Miami-Dade and Broward, are worth about $675 million a year in avoided flooding. And so the fact that our corals off of Miami-Dade are actually still doing well should give us some cause for wanting to protect them even further and research the ways in which this heat tolerance is being achieved. Here are the numbers, sorry. So about $355 million in avoided property damage and another 320 for economic losses. And this kind of leads to a project that we started just a year and a half or so ago that funded, of all agencies, by the Department of Defense, who decided that they recognize the value of nature-based solutions in protecting coastlines, and we're actually interested in protecting airstrips that are close to shore, often in small remote islands, and using coral reefs, for example, to try to protect that infrastructure. But they recognize, and this was really the quantum leap, they recognize that there's no point in just restoring reefs in these areas or building reef structures around them unless the corals that were being restored were somehow more thermally tolerant than the corals that had been lost. So they've invested really heavily and funded us a project here in Miami to investigate, engineer, develop, test ways of building thermal tolerance into Florida's restoration efforts and really doing it on a grand scale, which gets to the point that Mike mentioned. So we've got this project, and we're hoping to do this at a site near us here in Miami-Dade County to actually roll out and test new ways of restoring corals to make them more thermally tolerant, and at the same time, ways of building accelerated, what we call hybrid reef structures that can protect coastlines from storms. And it's my hope, at least, that as a coral biologist, we can marry those two efforts and use the tremendous interest in protecting coastlines that is, in everybody's bottom line, to use that as an opportunity to actually find the solutions that Florida needs, and so does the rest of the region and the world, to build climate tolerance into reefs and accelerate adaptive processes that might ordinarily take place but just don't have enough time to act. So it's kind of perversely an exciting time to be a coral biologist, even though it's also an incredibly depressing time at the same time.
Thank you. So I want to make sure we leave time for questions, but I'm going to hear from Jane first, and then Morgan about some of the things you guys are doing in response to this science. And Jane, you worked with Amy and Lynée on the heat study. So, and the county is considering this data for some initiatives. Can you talk about what you found and what you're thinking about maybe doing? What do you have in the pipeline?
Yeah. So as Amy mentioned earlier, we have chronic high heat here in Miami-Dade County, and this summer was yet another level of that. But so one thing we did was come out with a declaring, the mayor declared May 1st through October 31st as an official heat season, and charged my office with raising the public awareness about the dangers of heat on the level that we do with hurricane preparedness every year. So we have a good wheels in motion with our emergency management. We built on that. We also did a study of where people are having the most heat-related emergency department visits and hospitalizations in the county, where people live that are ending up in the hospital for heat-related illnesses. And the highest resolution we can do with health data is by zip code. But we have zip codes in the county that have 4 and 5 times the rate of severe heat-related illnesses than other zip codes in the county. And the top correlating factors are high poverty rates and high land surface temperatures. So our urban heat islands are a big factor in people being able to cool their homes, be able to stay cool at a bus stop, and when you layer that with income. So when I was first appointed as chief heat officer, we did have people say, oh, what do I need? We know, we've been in Miami a long time, we know how to handle heat, and if, like was said earlier, if you live in it and can afford your air conditioning, if you work in air-conditioned office, if you travel in your air-conditioned car, yeah, Miami's can be an inconvenience. Your kids can't play outside as much in the summer, et cetera, but it's not life-threatening. But the other area where we had the highest rates of heat-related illnesses is Deep South Dade, where our agriculture sector is. So it was a high percentage of outdoor workers. So outdoor workers, particularly in the agricultural field, can be up to 35 times more likely to have a heat-related illness. Construction, 11 times higher. So one of the things we've been looking at is, one, making sure all our departments within the county, we have 30,000 workers, many of which are exposed to heat during their workday, have a uniform standard, but also working with our commission on looking at what we can do to ramp up our education outreach. This past summer, we did 3 trainings for employers on heat safety in partnership with OSHA and FSU. They were booked solid, sold out essentially, so there is interest, but there's a lot more we can do on that front. We did trainings for summer camp providers. We did trainings at all our libraries and park facilities that serve as cooling sites, and partnered with community-based organizations to recruit disaster volunteers in our most vulnerable communities, so that people really have the basic information. And then building on what Lynée shared about people's exposure at home, one thing that our mayor and commission committed to was to make sure that everyone that lives under the county's care, in other words, our public housing, had access to safe cooling this summer. Thankfully, we installed 1,700 units, efficient units, but they're not, we have a lot to do on making the whole package lower greenhouse gas emitting of the home using passive cooling, insulation, and efficient AC systems. But at least we got people safe for this summer. And then we ramped up our investments in single family and multifamily home restoration. The last area, and I won't get into it in detail, but is a doubling down on cooling our neighborhoods through tree canopy investments. And so been working with all our departments on a plan to get to 30% from 20%.
Excellent. And then Morgan, your turn. So we're going to ask you about Biscayne National Park and a little bit about Andrew's project, which you all are considering doing in the park, correct?
I'm sorry.
Sorry, I got you while you were walking. So my first question was Biscayne National Park and how you all responded to the coral situation in the park. And then the second question is Andrew's project. I believe the park is considering having the park be the location for a pilot project.
Yes, okay. Let's take Andrew's project first. And I just wanted to say that the academics have, research community and the experts have applied to try out some of the heat resilient coral growth opportunities, as well as the hydro energy shoreline dissipation, or hydro energy dissipation at our shorelines to provide shoreline protection and test that out. It's going to be a long process on the government side. We're working through evaluating a couple of different aspects before we can get to that end. But
so, having covered the national parks for a while, I know that, I mean, it's national park land, it's sacred, it's very protective, so to get a project like this is kind of a big deal, and to have it in our backyard would be pretty cool.
yes, thanks. What we're doing about the heat, well, before we, as Andrew said, that we all kind of knew this was coming, and our ecologists and our managers on site have been preaching this for years and years and years, and they're ringing the warning bell. And yes, we kind of knew it was happening. We knew it was happening, and then we were watching the train come down the track at us. And this was the worst, unprecedented. We had never, ever expected this. In fact, we were actually thinking about what to do with sargassum mats instead. So as we diverted the energy, our ecologists at the park did massive amounts of fragment rescuing rescues, and they transfer them to Moat and U of M and other grow-out facilities, and so that a lot of the research areas have our coral reef specimens, fragment polyps in land facilities. Hopefully they will survive and then we can bring them back out. We also have USGS and other academics looking at experimentally moving these corals into temporary shaded areas, putting false or artificial shade over them, as well as moving them into deeper waters. And this is not happening at Biscayne, but at Dry Tortugas. In addition to the rescuing the corals, we're trying to just give the coral reefs more resilience. And this is heat independent, but what we, because heat is such a big stressor, anything we can do to help them be more resilient in other aspects, we try to do in the water. I used to say boots on the ground, but now I have to say something else, fins in the water or something. But that's removing the marine debris off of our ocean shores, bottoms, removing lost anchors, pulling up lost fishing gear and traps, ghost nets, just getting them off the bottom so that they're not wrecking and destroying the extant corals that we have there. We're adding mooring buoys in the park so that people can anchor, or tie off without anchoring and without losing their anchor, but also being able to still see our corals at the park. And there's always education, outreach. So whether you're out with our Biscayne Institute, which can take you out if you don't have a boat, or if you have your own boat, which is the primary way people visit our park, our law officers as well as our interpreter rangers are always really getting the word out, like, hey, protect yourself and protect the corals out there so they can be more resilient. And then one of the education ones here that I always have it in my mind is, of course, but to remind people, the mineral-based sunscreens are the best things to use when you're there. They're sticky, they're hard to rub in, they don't look cute, but they are helping our corals. So those are most of the things that we're trying to do to keep the corals as resilient as possible.
Okay, excellent. And I'm trying to keep track of the time, and we should probably take some questions, right? We feel like we might run a little bit over.
Well, thank you, all of you, for the great insights, as always. So I'm going to borrow 2 of the handheld mics, and I have some wonderful students that are going to walk through the audience. So can I see a show of hands? Okay, this gentleman has his hand up right here. When you get the mic, kindly return it after your question so we can take, I see lots of hands coming up, so we'll, oops, turn it on.
Hello? Oh.
There we go.
Thank you for doing this activity. I have about 12 questions, but I'll limit it to 2. I'll limit it to 2. The various corals, do they use or have the same algae symbiote, or they vary? Because I was very surprised to see that our ocean temperature is warmer than a lot in Israel. And I've been down there where they are doing the coral experiments, but I thought our water would be cooler, but it's actually warmer. So the first question is about the type of algae. And the other question, so I'll just turn it on to someone else, is as far as global warming, there's many, many changes. I don't remember earthquakes in upstate New York that you have now. So as the ice melts, then the plates change. But what about things like solar sunspot cycle, ocean vents, undersea volcanoes? I mean, these are all contributing as well. I mean, how do we know that in addition to our increase in carbon and fossil fuel burning, that these aren't accelerating as well?
Okay, so the algal symbiont question, Michael,
I can
and the
certainly
follow-up
answer.
question, Ben or Amy? Okay.
So you're correct. Corals don't just host one type of algae. In fact, there are many different species that are known to associate with corals. Here in the Caribbean, there's 4 main genera that have multiple species within them. And some are known to be more thermally tolerant than others, including one species that is found only in the Caribbean. And indeed, we do tend to find it. A lot of the inshore environments that Andrew was talking about, including some extreme environments inside the Port of Miami, the corals tend to almost exclusively host that thermally tolerant symbiont.
Can you take that one and insert it in a different species of
This is something that Andrew's group has been working on for well over a decade at this point. It may be possible, as far as trying to culture this symbiont and then seeding the entire reef tract, I think that would be really logistically challenging, but there has been some promise in seeding a coral. If you take a core out of a coral, bring it back to the lab, infect it, because it's called an infection. You infect it with this thermally tolerant symbiont, then go back out in the field and plop it back in. You can, in some cases, cause changes in the larger colonies, symbiont communities. But in reality, that takes a lot of personnel time and money and effort, and can take months to properly infect a coral. So I don't think it's the solution, but I think that the corals have a natural ability to respond to these stress events by modulating their symbiont communities. And that's how we see resilience and recovery of some populations. They tend to host that really tolerant symbiont.
Thank you.
Ben-
Oh, and the second part of the question?
So my father used to always tease me, and he's a scientist too, and he used to tease me, he says, it's the sun, stupid. So we get that question all the time, that solar cycles, could it explain the warming we've seen? And the nice thing is we can actually attribute that, quantify exactly how much the solar cycle contributes to the warming, and it's a very small fraction. So the warming we've seen since the 1950s, by the process of elimination, is really due to largely due to human activities. The volcanoes are an interesting question. If the volcanoes are on land, they shoot a bunch of sulfate aerosols, and if they get into the stratosphere, that can actually cool the climate system for a couple of years. Volcanoes in the ocean, if they put a lot of water vapor into the atmosphere, water vapor is actually one of the most potent greenhouse gases, and so that water vapor can actually serve to warm the climate system. The distinction is that water vapor has a life cycle, half-life of maybe a couple of weeks in the atmosphere, so it cycles through rather quickly. If you compare that to CO2, it has a half-life on the order of 4,000 years. So the CO2 that we're putting in the atmosphere today is going to be there for a very, very long time. So that's what the dominant contribution is. Yeah, we don't. Well, yeah, they contribute to the methane and CO2 that's in the ocean, but they're not really contributing very much to the CO2 that's in the atmosphere, nor are they warming the climate system of the ocean very much, not compared to the other processes.
We had a question, Ryan, this lady right there. Mic on?
Yep.
No, Ryan, can you turn it on for her? Thank you.
We got the light. My name's Diane. I come from Palm Beach County, and I just want to thank all of you for the work that you're doing and for this evening. I was happy to be brought here by a friend, and I talk trash up in Palm Beach County because I do marine debris. I've been diving for 30-odd years in Palm Beach County and around the globe, and I understand a polyp from when I was little. You brought, Andrew, I think his name is, you brought it to reality in talking about flooding and talking about property values and whatnot, bringing it into people's homes to understand that saving the corals is something we all need to understand in order to vote correctly and know that there's somebody doing something about it. Along with you all, you need the powers that be to be doing the right stuff for all of us. So I thank you all for the work you're doing. And I want to, just sounds like a very educated group. I challenge you all to bring a friend or two to the next event, because getting more people to understand all of this is very important for our survival, because the ocean is our survival. So thank you very much.
Thank you. We have a question here in the front here. It's on, right?
Thank you.
It should be on.
It's on?
Yeah.
We've been talking about the thermal phenomena. But have we, or are we able to distinguish between what I'll call contamination, poisons, runoffs from the rivers and agriculture, and we here on Key Biscayne, we're constantly getting reports in the summer that don't go in the ocean, there's so much bacteria and all that. So in addition to the thermal component, what are we discovering with regard to contamination?
With respect to corals?
With respect to whatever it's impacting, coral in your case, but whatever else is, it's killing fish, obviously. It's doing all kinds of things.
It's true, and there are synergistic effects or antagonistic effects, but it's very difficult to tease out those impacts. You need to have a really advanced ex situ system, so a lab-based system to really untangle the interactions of those things. So something that we are doing here on campus is incorporating robots, of all things, into our tank systems to be able to precisely dose different stressors. So we can simultaneously apply heat or nutrients or disease, all kinds of different stressors to see how it impacts, in our case, the corals. And I'd like to use the analogy that corals are really just dying by 1,000 cuts at this point, because it's just tons of small things that don't seem to be that impactful on their own, but they added in with everything else that they have going on results in widespread mortality. Yet, I think there is a silver lining here. So one of my favorite places to dive in the area is not where you think. It's inside the port. Exactly, yeah, it's very strange. It's usually about 3 to 5 feet of water. I'm diving in muck, with trash all around me. This summer, it was 93 degrees Fahrenheit in the water, so it's like taking a hot, stinky bath. But there are these amazingly beautiful coral communities that have been growing on artificial substrates. So on people's docks, on seawalls, on riprap, which is a type of boulder used to stabilize shorelines. These corals are surviving, and these corals are constantly being hit with temperature, nutrients, sedimentation, everything, and yet they're doing well. So I think, just like Andrew said, that in a time where everything seems to be going wrong, it's almost like gives us a really unique opportunity to look at how corals are able to naturally adapt to their environments, particularly in really challenging situations, and then to use those same mechanisms to breed corals that will be able to survive in the next century. So I think there's definitely some negative impacts of everything that we are doing to our coastal communities, but also there are some silver linings.
We are at 5:02. I think we've come to the end of our program, unless there's any other questions. If there are, we invite you to head. Oh, no. Look at this. All right, this is great. One more question, then we're going to let you know to join us again on November 8th for Water, Water Everywhere. But we can also continue the conversation for those of the scientists and panelists that will stay at the wet lab. There is a tap takeover at 6 o'clock to help debris-free oceans and a couple other good working organizations in the community. So give me one last show of hands, one last question, right here in the striped shirt.
Good afternoon. My question is about energy usage and how is there any hope for us? My premise is that as standard of living goes up, people use more energy. And I read this article that expressed energy usage in barrels of oil equivalency, not necessarily all oil, could be nuclear, solar, whatever, but equivalency, so you compare one to the other. And we as Americans are at the top, approximately 27 barrels of oil equivalent per year. Europe is 23 to 24. But of course, if you take United States, Europe, and Canada, we're less than 1 billion people. China, in that same article, is listed as 9 barrels of oil per person, 1.2 billion people. And India was only at 2 barrels of oil per person. So I started doing some calculating. This was not in the article, my off-the-cuff calculations. I have 8 billion people, a few of us use in the 20s. How about worldwide average is 8, somewhere around that? And if over the next few decades the standard of living goes up, would it be very surprising? We'll never get to in the 20s worldwide, all 8 billion people, but let's say we get to 18. So if we're at 8 or 9 now, and we go to a worldwide average of 18, wouldn't that double the total energy used in the world? And then if we top out, as I read, at somewhere between 10 and 12 billion people on the planet, so 1.25 to 1.5 what we have now, so you have 2.25 multiplied by 1.25, 1.5, 1.33, you come up to almost 3 times the energy usage that we use today.
Sir,
so
and
my
your question, I'm sorry, what is your question?
The question is, if we go to almost tripling the energy, how is there any hope? How can we use reusable, how can we ever do it without burning more and more and more fossil fuel? How is that possible? What is the hope?
I mean, I could take a crack at this. You're right, that's the problem. And that's, I think, that's an important takeaway here, that burning fossil fuels is at the root of all of what the issues that we're talking about here. And we don't have, many of the answers are out there, and I'm not an expert on this, but the experts talk about a suite of solutions in terms of different energy sources. And it is possible, and we should be working towards that. And we have a lot of researchers here who look at the role of different actors, government, corporations, individuals. There's a role for each of those, but the most important thing, in my opinion, is to be driving towards policies that allow us to transition from fossil fuels to green carbon. And as individuals, we can have impacts in our own personal choices, but we don't get to decide what the energy is behind the light switch or the air conditioning. So that's one answer. It's not really the answer, but the answer is we need to move towards a non-carbon-based economy because the energy demand is going to be there.
Yeah, and just to add to that really quickly, when we talk about what needs to happen to achieve this energy transition, right? There is that side, which is switching over to carbon-free, even carbon-removing technologies, but there's this important behavioral side. And in part, that is also updating all of our technologies, right? So going to what Jane was talking about, that's weatherization. That's things like having really efficient AC. So it's not just pushing forward our energy system, it's pushing forward everything that is sucking up the power and making sure that it's using less. Because from a justice point of view, it's really important that these developing countries do get to have access to the same energy that we get. So it's a glut problem on one side, and it's an insufficiency problem on the other. So we want to make sure everybody can have energy to have a quality of life that is good, that is middle class supporting. And to do that, we need to advance our technologies, get those technologies implemented, making sure we can get them to the homes that really need them, so our poor homes, our homes in developing countries, and just recognizing there's multiple levers that we're pulling. It's not just a renewable energy problem, it's everything else along the way.
Thank you.
Also, just one point, sorry. Don't despair. Despair leads to inaction. So I think it's really important not to despair. There are many, many things we can do, and we're doing them. We need to do them faster and better, but please, don't despair. There's lots that can be done.
Thank you all for joining us, and hopefully we'll see you and a friend or two on November the 8th, same time. If you have further questions, feel free to email me. I'm on the Eventbrite, and we'll get your questions answered. Thank you.